Okay, so today we're going to go over fossil-bearing sedimentary rocks and modes of life. If you have any problems hearing me or if you have any questions, feel free to send a message at any point um, and let me know what the issue is. This is my first time using this program, so if we can stop and fix the issue, we should do that as soon as possible. You got that? Okay. Okay, so the first thing we're going to go over is fossil-bearing sedimentary rocks. We're going to be going over limestone, shale, sandstone, mudstone, and coconut today. Before we get started, I wanted to go over the definition of the word clastic because we're going to be using that today. And basically, there's two types of sedimentary rocks. There's clastic and chemical sedimentary rocks. Chemical sedimentary rocks are usually composed by the dissolution of aqueous solutions, and so usually they're not in an environment where there's going to be many animals or insects, so there's not going to be a lot of fossils as a result, and there's not going to be buried either. So clastic sedimentary rocks are composed of fragments or clasts of pre-existing rocks or minerals. So this means that usually we start off with igneous rocks that are, for example, on the top of a mountain or a hill, and as they get weathered, either through rain or through sunlight or animals, they get broken down into smaller pieces. And as they move towards the ocean, usually through a river or through rain, for example, they get smaller and smaller and they break down as they go along. And once they are at the coast or in the ocean, they lithify and they are compressed together to form sedimentary rocks. And this is the most common type of rock where you're going to find fossils. And these are just the most common types of rocks that fossils are found in that we're going to go over today. So today we're going to go over this, and we're also going to do modes of life. So the different types of feeding that animals do. Okay, so the first thing I wanted to go over before actually getting into the rock types and the fossils that you find in them is the idea of facies. I put the definition here for you. Sedimentary facies are bodies of sediments that are different from adjacent sediment deposited in a different environment. So basically what that means is that as you move towards the middle of the ocean, in this case, the rocks that are in the middle versus the rocks that are on the coast versus the ones that are towards the deep sea are going to be very distinguishable from the ones next to them. So like this picture here shows, the sandstone facies are very distinct from the shale facies, and which are also distinct from the limestone ones. As you move towards deeper oceans and the water's cool, the finer sediments are going to settle towards the middle, and the more grainy coarse sediments are gonna settle towards the coast. And so this is just something to keep in mind. And there's actually two different types of facies that we can use to identify and distinguish rocks. The first is lithic facies, which is what we're going to be using today, which is rocks are distinguishable by the size of the sediments and the type of sediments that they're composed of. And the other type that we're not going to go over as much is biofacies, which is when you distinguish rocks based on the type of animals that you find in them. Because in this case, most of the animals, they're not gonna vary that much, but the rock size and their composition of the rocks, they're gonna vary quite a bit. So if you have any questions, let me know. And I'm gonna give you a couple seconds just to, if you're taking notes, to jot them down. Hey Connor, are you still there? Okay. Um, so the first thing we're going to go over is limestone. And limestone is primarily composed of calcium carbonate in the form of calcite. When we look at limestone rocks, they have to be at least 50% of calcium carbonate. Another alternative to calcite is aragonite, um, but it's not as common. It's mostly found in clear, warm, shallow marine waters, so it's the type of environment where um, calcium carbonate producing animals are going to live. Things like brachiopods, corals, shellfish, basically anything that produces a hard shell, it's going to produce the calcium carbonate that these rocks are made out of. So limestone that contain fossils are called fossiliferous limestones. So based on this, we can make assumptions about the type of fossils that we're going to find in limestones. So do you have any idea what kind of fossils you might find in limestone? That's close. But actually, the most kind of fossils that you find in limestone are going to be those same animals that create the calcium carbonate that is later compacted into the limestone. So if we look at these fossils, for example, we have ammonites and we have another conglomerate that's made out of broken pieces of other shellfish, as you can see here. And limestone is usually gray, but it can also be tan, white, or yellow, and it's soft and fine grained, so you can actually scratch it really easily. And one way that you can really easily identify limestone is if you drop any kind of acid, it'll bubble up and release carbon dioxide. I put this chemical equation here so you can see why that is. So if you remember, calcite is calcium carbonate, and if you put hydrochloric acid or anything else that starts with the H proton, then it's going to release water and carbon dioxide. So that's just one of the easiest ways you can identify the limestone. The second thing we're going to go over is coquina, which is actually a variant of limestone, but it doesn't have that much limestone in it. It actually acts more as a glue that keeps the rock together. And so coquina is actually the Spanish word for shellfish or cockshells. It's composed of wholly or almost entirely of pieces of mollusks, corals, trilobites, brachiopods, or other invertebrates. Anything that has other shelled invertebrates. Anything that has a shell will be part of this coquina. And they must be bigger than 22 millimeters in size to be considered part of that rock. So this is what a coquina looks like. So like you can see, it's basically just a bunch of fragments, and even some of them are almost whole. You can see how these shellfish are still basically put together on this rock. And so the limestone is just going to be everything that's in between these rocks, in between these shells, holding it together. And it's really easy to identify because no other rock has this distinguishable look. It's basically a bunch of shellfish stuck together. Do you have any questions? Okay. So the next thing we're going to go over is a mudstone. This one's pretty easy too. It's basically rocks that are composed of hardened mud. They're formed deep in marine environments where the grain is fine. You're going to find things like silt and clay that settle. Characteristics are that they're generally quite soft, but when they harden, they can be brittle, meaning they can break easily. They're usually gray, black, white, but they can also be red, green, and blue, just depending on the minerals. And I don't know if you have to know yet, but they are usually composed of quartz, feldspars, and micas, micas are the darker ones, the darker colors that make it gray and black. And they're usually quite smooth to the touch. Okay, so this is just an example of a mudstone that has a fossil imprinting on it. It's like you can see, it's a lot darker than the limestone. It looks kind of similar to the coquina, but these are actually not the shells. These are just the imprints made inside of it, and it's also a much darker color. And the next thing we're gonna go over is shale, and shale is actually a subcategory of mudstone. So shale is a fine-grained sedimentary rock that is composed of clay and quartzite as well. It's characterized by its smoothness and its splintery layers, also known as its fissility. So when you break open any piece of shale, you're going to see the layers very distinctly. And again, it's going to vary in color. It is going to be quite dark. And these are just a couple of photos. This is what I really want to emphasize about shale. When you break off pieces of it, it has these planes that are laterally horizontal. So that's kind of the most defining characteristics when you want to define something, when you want to identify a rock. And shale does vary in color. If there's iron in it, it'll be red probably. If there's micas in it, it's going to be this dark color. It just depends on the environment. And there's all kinds of fossils that you can find in shale. They're often marine just because shale, again, is a rock that is formed in a marine environment. So you are going to find a lot of marine reptiles, but you can also find things that are terrestrial that where shale used to be in a marine environment, but then just due to plate tectonics and the movement of it, it was no longer in that environment. And I just have a picture here of a trilobite, for example, which is a terrestrial animal. And then on the other side, we have a marine reptile. So it does vary in size a lot too. Okay, so the next rock that we're going to go over that contains fossils is sandstone. So sandstone is a clastic sedimentary rock composed of mainly sand-sized minerals or rock grains. If you don't know what sand size means, there's actually a technical definition for what we consider sand. So when we go to the beach, anything that is between 1/16 to 2 millimeters in size is considered sand. Anything that's bigger than that is considered gravel, and anything that's smaller than that is considered silt. So sandstone is usually formed by the weathering of larger rocks. Like we talked earlier about rocks that are weathered and are brought down to the coast, usually through rain or through rivers. As they move towards the coast, they're compacted and they cemented together. And there are different kinds of materials that can act as cementation. One of them is limestone, like we mentioned earlier in the coquina, and another one can be hematite, and another one is actually gypsum. So just so you have the information, these are all minerals that act as glue for other types of rocks like sandstones and the coquina. And most sandstones are going to be a lighter color. They're going to be composed of quartz or feldspars. Feldspar is a kind of mineral that's actually one of the most common minerals on the planet's crust. So that's why most sandstones are made out of it. And feldspar is more of a general term, and that includes a bunch of other minerals, but most commonly is plagioclase and orthoclase. And also, Connor, if you have any suggestions for me that will help you, let me know. Like if you want me to, make some drawings, or if you prefer that I write on the board, or if you need more time for each slide, just let me know, okay? And as for the color, it also varies a lot. Yeah, I would do that. The color in sandstones varies a lot, but just like when you go to the beach, the colors are going to be tan, brown, yellow, but usually it doesn't vary that much. Occasionally you get green sand and you get purple sand, and so you get some really pretty rocks, but usually it's pretty consistently goes. Oops. Oh, those are just examples. Those are just examples of common minerals in sandstones, because sandstone is formed mostly of quartz and feldspars. So here and here. And plagioclase is just an example of feldspars. Orthoclase is just another example. Hematite, gypsum, and limestone are minerals that cement other rocks together. So like we talked about earlier, coquina, this rock, for example, is cemented together with limestone. All those shells need something that keep it together, and hematite and gypsum also act similarly. So there are some rocks that are held together by hematite, and there are some rocks that are held together by gypsum. Okay, so these are just some images of sandstone. Usually they're going to vary in color, but the one thing that you can notice that I think you should notice about them is their texture. So you can see all these little dots here. That's the sand grains. And here on the right, I have a picture of what's called a pure quartz arenite sandstone, meaning that the whole sandstone is going to be composed of quartz. It's going to be purely quartz. There's not going to be other minerals in it, and that's why it has that really white color. And if you didn't know, orthoclase is actually this reddish pink color, so that's why we have this kind of rock that's not that dark, but it does have spots of quartz and orthoclase in it. And as you get deeper into the ocean, your rock actually gets darker. So you're going to have spots of black and you have spots of white, which is actually what we call micas. So I know that looks horrible. Let me turn it over here. Okay. So do you have any questions? Okay. And this is just an example of a fossil that is found in sandstone. It's called Archaeopteryx. And basically, it's just to show you the difference between the color in a rock like sandstone and a rock that we looked at earlier like shale. So it's pretty much quite easy to distinguish them based off their color. But also the texture is going to be much grainier when you touch a sandstone rock. Okay, and I have a short quiz, and we have a couple minutes, so if you can answer these questions for me, then that would be great. You know, I forgot to actually mention the one for number 2. Well, I mentioned what it was, but facility is actually that platiness we talked about. When we look at the shale, and if we break a piece of shale off, and we look at those layers, all those parallel lines, those breaks that kind of look like stairs when you break open a piece of shale, that's what we call facility. Sorry, I didn't mention that earlier. Facility is the platiness or the weakness in the lateral. Let me just show you. The property of rocks to split along those planes laterally. So basically, these thin sheets is a characteristic that we call facility. How it looks like when you break it, there's different distinct layers. So it kind of looks to me like a case of stairs. That's what I would call it. Like this. So if you want the definition, it's right here. Can you answer the third one? That's actually not right. The direction in which the sediments get finer is away from the coast. Yeah, okay. So as we get deeper, you're right. As we get deeper into the water, the sediments do get finer. So the sandstone that's found at the coast is going to be the grainiest, and the limestone that's found towards the middle is going to be the smoothest and the softest. It's going to be actually the easiest to scratch. What about the third one? I mean, the fourth question. Okay, good job. Okay, so we're gonna move on to the next section. If you're ready, if you don't have any other questions, I mean. Yeah, if you ever need to go back or just need more time, let me know. We'll go back in. Okay. Okay, so in this portion, we're gonna go over modes of life, basically how animals eat. And because we are studying fossils, all the examples I'm going to use are going to be ancient animals. Um, so this is going to be pretty easy as far as the types goes, because I think most of us have had exposure to this since early on in our, since elementary school. The first type of mode of life is actually a predator. And the definition of a predator is an animal that lives by killing and eating other animals. Basically, an animal that preys on other animals. And the example that I wanted to use is a T-Rex, just because it's the most commonly known, the most famous predator. And not only that, but all theropods are predators. And if you don't know what a theropod is, it's a type of dinosaur which is three-toed. So all three-toed dinosaurs are called theropods. They usually have claws, they usually have big teeth, and they usually are predators. Which actually brings me to the next slide. Oops. The thing I wanted to mention about predators is that they have pretty common characteristics, at least when it comes to terrestrial predators. For example, I have this photo. It's of another predator. It's called a Spinosaurus. And I wanted you to notice that, like um, like the one earlier, which had a net, we can compare that also to the baleen whale that we see today. It has like a brush-like mouth, and their diet is going to consist mostly of phyto and zooplankton and small invertebrates, maybe like shrimp or things that don't have shells, basically. And this is a photo of a marine reptile, um, and I wanted to show you its teeth specifically because how close they are together and how they're so needle-like. And this specific reptile does not, the upper jaw here, this upper jaw here doesn't move. It's actually positioned like that permanently. Okay. All right. And the next thing we're gonna go over is called a benthic feeder, and this type of feeder is the opposite of a pelagic feeder. Basically, it just means that the animals feed either at the bottom of the water in the sand or on the coast. So everything but the middle area is considered a benthic area in the ocean. So within that category, we do have other types of feeders, such as deposit feeders and suspension feeders. So an example of a benthic feeder is a filter feeder like this sea star. I have a picture of both the um, fossil of one and then a very similar modern day one. So the tentacles here are used to capture bacteria or plankton or diatoms, whatever it is that it's going to be eating. And so the animal is both a filter feeder and also a benthic feeder. Do you have any questions? Okay. So the next thing is a deposit feeder, and deposit feeders are actually benthic feeders because they feed at the bottom in the ocean. Well, the definition is feeders that obtain food by moving through soil or sand. They can be terrestrial, so if we think of things like worms, but they are also found a lot in marine environments. So it usually only works in areas where the soil is going to be moist, something that they can actually move through. If you think of somewhere with hard rock on the ground, then you're not going to find any earthworms or any snails or any other animals living there. For marine deposit feeders, they target something that coats the surface of the rock and the sands, and it's actually called detritus. So things like crabs, snails. I have this picture of ancient snails, just as an example. Other worms, sea cucumbers, all those things are targeting detritus, which is made of bacteria and also the remains of other dead animals. So, for example, when a fish dies, it it sinks to the bottom of the sea, and it starts to decompose. And all that bacteria and all those remains and all those fragments are absorbed into the dirt, the nutrients from it. I mean. Oh, and this word here, diatoms are single-celled plants, basically. Single-celled organisms that are plants. Okay, so the last one I wanted to go over is called a fluid feeder. Um, this one's pretty simple. I didn't have a lot of examples for ancient fluid feeders, but basically it's defined as an animal that gets its nutrients by consuming the fluids of the organisms. So if we think of modern day examples, that would be things like spiders, bats, mosquitoes, hummingbirds, and basically the only example that we have from the ancient world is fossilized mosquitoes and other insects. So do you have any questions? Okay. So I have another short quiz for you. That's right. So benthic filter feeder means a filter feeder that's going to be close to the bottom of the sea. Mm-hmm. A pelagic filter feeder. Dolphins are predators. They eat fish. So maybe something like a whale. Yeah. That's okay. And number what is one clue that a terrestrial animal is a predator? So theropods is a subgroup of dinosaurs that has 3 claws and big teeth. So those are going to be the clues. Theropods is actually just the name of the category. Yeah, so the big dagger-like teeth is the clue, and theropod is just what we use to categorize them. Yeah, okay, good job. So just be sure to review the sections from before. And do you have the PowerPoints available to you? You don't. Okay, well I'm gonna find out if we can send you the PowerPoints that we've done before and for your previous classes, just so you can use them to study, okay? Because I know that sometimes when we're going through a class like this, you don't have time to take down all the notes or it, you know. So I'm gonna find out with the center. Okay, I can go back for you if you want. This one, right? Oh, okay. All right. Well, yeah, I will ask Joyce or Miss Chris about it, and then hopefully we can send them to you. Okay. All right, and that's gonna be all.